Good morning, dear beloved students. In this session, we're going to continue what we have started before about the gene localization. So we started first, we have some notes, we have to know them. If you have to verify that the affected allele is recessive, we have to look at two normal terms. We have an affected child. However, to verify affected dominant allele, two affected persons, we have a normal child. Location of a gene, we said that either it's going to be autosomal, meaning that's from chromosome number 1 to chromosome number 22, it's on autosomes and not on the gonosomes. Otherwise, it's going to be gonosomal or it's called sex-linked, either on the non-homologous part of Y, or sometimes we mention it as non-homologous region of Y, non-homologous part of X, homologous part of X and Y, and these are the four possibilities. Either autosomal, either a non-homologous part of X, non-homologous part of Y, or it's the homologous part of X and Y. Always and always and always, I will give you a hint in the text. Mostly. Sometimes I didn't. Mostly, there is a hint in the text that mentioned, for example, that this disease, the gene of this disease is located on the chromosome number 10, let's say. So this is called the hint, and this will help you to determine that this is autosomal. So you're going to focus on X, Y, and XY to deny it in order to reach the autosomal. Otherwise, to verify it if it's located. These notes, someone of you, they asked me, do we have to study these? I said no. You don't have to study them. You have to understand them more than studying them. For example, in this case, to verify if the gene is located on the non-homologous part of Y, only males will be affected. Since males, they have the Y chromosome, and the girls, they have XX. If it's not, so it's not the case. Or another case, every affected son should have an affected father. So every affected son should have an affected father. So here, if the gene is located on the non-homologous part of Y, if the gene is located on the non-homologous part of X, every affected daughter should have an affected father, since it will inherit. These are in the case of recessive, since this female will inherit XD and XD from each of her parents. So XD will be maternal and XD will be maternal. So here, paternal and maternal origin. So XD from the father, so XDY will be. So if it's XDY, it will be affected, but it's normal, so it's not the case. Also, to verify if the gene of the disease is located on the homologous part of X and Y, what you have to do, you have to say that the recessive daughter and the recessive son should have a recessive father. This is the justification for the four cases, whether it's X-linked on the non-homologous part of X, Y-linked if it's located on the non-homologous part of Y, or if it's located on the homologous part of X and Y. Here in this pedigree, we determine this. Always, I will say that you have to look to the pedigree. The pedigree is the way to solve the exercise, or it's the key to solve any genetics exercise if you have pedigree. So pedigree is very important. This pedigree allows to determine whether the allele is dominant or recessive, whether the allele of the gene or the gene is located on the X or on the Y or on the XY or it's autosomal even. All of these, they are on the pedigree. Whenever I ask in the question or in the quiz, I ask you, for example, is the allele responsible for the disease dominant or recessive? Justify your answer. If you didn't use the pedigree and if you didn't explain according to the pedigree, even though you answered correctly, even though you gave a correct answer and you said that the allele, for example, it's recessive with respect to the normal, and you gave symbols for this, and you didn't use the pedigree and you didn't justify basing on the pedigree, based on the pedigree, this means that your answer is not correct. You will not get the mark for this part. So pay attention to this. This quiz, I'm going to be so strict. I'm going to be so strict in correction of all the parts. You have to pay attention to all the action verbs. Every verb at the rhyme of Wi-Fi, you have to justify. Whenever I said indicate, let's say, or give or name, you don't need to justify. Extra factorial analysis, if you have to do the factorial analysis, you have to be starting from the same steps, using your pencil and the ruler to draw the table of cross and the table of process if we have to do so. So here you have to pay attention to this. These are very important. So I'm going to work and deal with these quiz as I'm going to deal with grade 12 students. So here, discuss logically the chromosomal location of the gene. First of all, I don't know if the allele is dominant or recessive. Second, I don't know what are the symbols of the allele. Then I have to move to discuss the chromosomal location. So you have to pay attention to these. These are very important. For example, you can't start saying whether the allele is dominant or recessive without saying it's dominant or recessive and without giving the symbols. You are going to move deeply to say that it's located on the X. No, it's not the case. How did you use the symbols? What are these symbols? Explain this. So you have to pay attention to this. Even though I didn't ask you to designate by symbols, you have to do so. This is according to the pedigree. For example, sometimes I'm going to ask you to determine the risk. What is the risk for the individuals to have an affected child? Risk meaning that you have to look for the probability. So you have to do either factorial analysis right now. Next year, we're going to move to the probability and to solve it as probability. But this year, whenever you ask, determine the risk for couples 1 and 2 to have an infected child, what do you have to do? You have to do factorial analysis and you have to see these results according to this pedigree. Okay? Next, I have to mention the names of the members of the family 2, 1, 2, 2, 2, 3, 3, 1, and so on, like down here. So you can say 1, 2, they gave birth to individual 1, 2 that are affected. Thus, I'm going to cancel all the answer because we have 2, 1, 2, 2. So you have to say 1, 1 and 1, 2. They are normal, but they gave birth to affected children, 2, 1 and 2, 2. So the allele of the disease, it's masked in the parent. It's recessive with respect to the normal dominant allele. Okay? So then I have to give the symbols. Let, for example, N capital. Some one of you asked me, do you have to give always N capital? Can we give another symbol? Sure, you can. You can give another symbol. It's up to you. So let's move now. So the gene here, it's autosomal already. We finished this exercise and we solve it. I want to be focused on this question. Already we solved the parts 1 and 2, but I want to move to talk deeply about this question. So the synthesis of hemoglobin is due to a gene localized on an autosomal chromosome. Here they gave you the hint. Not always they will, but here they gave it to you. It's located on the autosomal. So the gene is autosomal. The gene is present in the cell of an individual in two alleles. One allele is paternal from the father, and the other is maternal. The two alleles are allele N that determines the synthesis of the normal hemoglobin. So allele N or N capital, so it's the dominant, and allele N small that determines the synthesis of abnormal hemoglobin. A person has normal hemoglobin if he has two alleles, N and capital, or it has N capital and N small. This sentence, if I told you pick up from the text the sentence that showed that the allele of the normal hemoglobin is dominant. Here, this is the sentence. Why? Because the allele of the normal hemoglobin, it can be expressed in both homo or hetero, and homozygous or heterozygous. So here, the allele it can be expressed in both homozygous and heterozygous, so it's the dominant allele. So the dominant allele is the one that is expressed in both homozygous and heterozygous. Here one of the questions. Take out from the text the statement that shows that the allele of the normal hemoglobin is dominant over that which is the abnormal hemoglobin allele. Justify your answer. So this is the statement. Justify because the dominant allele it can be expressed in both homozygous and heterozygous. However, the person with abnormal hemoglobin, it has two alleles, and small and and small. And small and small, meaning that the allele for the abnormal hemoglobin, it's recessive. Why it's recessive? Because it's only expressed in the case of homozygous or pure. Well, this is the one that is recessive. Here we continue. The pedigree in the adjacent document shows the appearance of abnormal hemoglobin in the family. First, according to the pedigree, determine the gene localization of the hemoglobin gene, where it's located. Before I start this question, I have to determine whether the allele is dominant or recessive, and I have to continue. Here, you can say, for example, it's already given, but in other questions, you have to say A and B, they are normal, but they gave birth to affected children, C and E. Here, one of you asked me, why did you say 1A, 1B, or 2C, or 2E? Here we don't have, we have other than A. We have only one A, and we have only one B. Only one C and only one E. That's why I used only the letters. Okay, these notes you have to know them. That's why I'm focusing on these notes. So A and B they are normal, but they gave birth to affected children, which are C and E. So the allele of disease it was mass in the parent. It's recessive with respect to the normal dominant allele. Already we have the symbols, and then we move. If we have to deny it on the Y chromosome, we have to deny it on the Y chromosome. None of the females should be affected. So none of the females should be affected, but you have female E is affected. So it's not the case. Why? Because it doesn't have the Y chromosome. So it's not the case. Or you can say if secreted the Y, every affected son should have an affected father. So here it's not the case. So here we deny it on the Y. Second, I have to deny it on the X. Every affected daughter should have an affected father. Affected daughter here, it's just one. It has two X's, X and X. So X and small, X and small. It should inherit XM from the father, which will be XM, Y, and it will inherit from the mother XM, and the other will be, let's say, X and capital normal. But if this is the case, so this individual A will be affected since it has X and small y, and the gene if it's located on the X chromosome. So it's not the case. Also, if it's located on the X and Y, this individual it has X, it's affected. So it has X and small, Y and small. And this individual it has X and small, Y and small. So in this pedigree, it will inherit XN from the father, and sorry, this one XN, XN, sorry. XN, XN, and XN, YN. So here, YN for sure will be inherited from the father. And XN for individual C will be inherited from the mother. And for individual E, XN from the father and XN also from the mother, which seems to be affected, but is normal, so it's not the case. From this pedigree, we can determine that the individual or the gene is located on the autosomes. Part 2, referring to the text and to the pedigree. Specify the two alleles present in the cells of father A, mother B, and daughter E. First of all, I'm going to put all the genotypes. If there is a specify, so sure I have to justify. If I didn't justify, this means that I didn't give the answer completely and you will not get any mark on this part since you didn't justify it. So any verb at the rhyme of Wi-Fi, we have to justify. Otherwise, it will not be a correct answer. Okay, so here it's autosomal, and this person A and B they are normal. So sure they carry the amine and capital and allele and capital, but they have affected individuals C and E. C and E they are and small and E is and small, and we can also say H it's and small and small. All of them they are n small and n small. Okay, so here they are affected, but To C and to E, they are affected, so they inherit N from each of their parents. They should be heterozygous, having N capital and small. Okay? So let's repeat. If I wanna specify the genotype, I can work, if they ask you for the whole pedigree, C, E, and H, I can work all of them together. Why? I can say C, E, and H. The genotype of C, E, and H is M small and small. Why? Because they are affected by the abnormal hemoglobin, and the allele for the abnormal hemoglobin it's recessive with respect to the normal dominant allele, and it cannot be expressed unless in the case of homozygous. That's why it's M small and small. So here I finished justification for this. Next, A and B, they are normal, so for sure they carry the allele and capital. But they gave birth to affected children, C and E, having genotype and N, so they should inherit N from each of their parents, who should be heterozygous. If they are homozygous, all of their descendants or all of their offspring will be normal. Moving for individual D is normal, so it can be either an N or and capital and small. How can we determine this? We can't. From this pedigree, we can't. Moving to F. Individual F is normal, so it carries the allele and capital for sure. But she gave birth, couples E and F, to affected individual H, who should inherit N from each of their parents, so it's obligatory will be N capital and small. G will be N capital and small, or N capital and capital. Who can tell me if this is correct or not? G, it can be, yes, Tala. It can be uncapital or uncapital and small.
Um, Only on capital and small
Why?
because parent E, the
Yes.
mother has an N, so
So
it should
obligatory
inherit the
to
small
transmit
N.
only and small. Very good. So
Mm.
here, no possibility for uncapital uncapital. It will get uncapital from here. The other uncapital, it can't get it. So here is the problem. Thank you, Tala. Here, let's continue to 43. They said, make factorial analysis to verify the phenotypic and genotypic proportion of the couples E and F. What are the phenotypic and genotypic proportion? How many children do they have, couples E and F? They have two. One of them is affected and one of them is normal. So 1/2 is normal. 1/2 they are normal, and 1/2 they are abnormal. Okay? These are the proportions here. 1/2, they are abnormal. So here from this pedigree, I have to do the factorial analysis to verify the phenotypic and genotypic proportions. For example, بيجي مهدي أو بيجي علي أو بيجي محمد, we want to work in this in percentage. And I ask you, I need it in a proportion. So simply, I'm going to cancel the part if it's in percentage. Since I asked for proportion and I didn't ask for percentage. Here, individuals E and F. E is the affected individual. So E is affected. The female is abnormal, while the male is normal. So let's move to do the factorial analysis. Factorial analysis, as usual, you have to start with the phenotype, phenotype, male and female. The female, it was the affected, so it is abnormal, let's say, abnormal, in order to change, not always affected, abnormal or diseased, we can say. And here is the normal one. The genotype of the individual F, it's heterozygous, and we said it's N capital and small. So the male is N capital and small. Crossed with the abnormal, it's N small and small. This is the female. Moving now to the gametes of the symbol gamma. Gametes of symbol gamma. Here we have two different gametes, and capital and small. And capital and small. And capital, it's 1/2, and small, it's 1/2. However, in the female, you have only one type of gametes, which is n small 1 over 1, or you can say only 1. Moving now to the table of cross. Table of cross, sure, in pencil and ruler, for sure. So this is the table of cross. You have to divide it into male and female. So here, this is the male, and this is the female. Male, it has m, which is half, and n small, which is half. And here it's only n small 1 over 1. So here n capital times n small will be n capital, n small 1 over 2 times 1 over 1 will be 1 over 2, and n small will be n small and m will be also 1 over 2. Moving now to the table of result. Let's write here table of costs. Okay, table of costs, table of costs, and here is the table of results. From the table of results, you can simply do like this. You can do genotype and phenotype. So the genotype of the individuals, they are N capital N small 1 over 2, and N small 1 over. Okay, here we continue with N capital N small 1 over 2, so half of them they are normal and half they are affected or abnormal, since we use abnormal before. So half normal, half abnormal. Then I have to say to verify the results on topic and genotypic proportion. I have to say therefore results are verified. Results are verified. Okay. So this is the question. Yes, Ram, do you have any question?
أستاذ نحن إذا بهيدا السؤال بدلناهم يعني بس
بدأنا
غلطنا
male and female.
إيه يعني بس
All of
نفس
it is wrong.
الجزم.
Wrong. None of
طيب
the marks you will have because you didn't know that the male is affected and the female, for example, or the opposite. Here, the male is normal and the female is affected. Okay, so you have to pay
أوكي
attention to this trend. Pay attention to the male and the female. إذا قلبناهم, if you reverse them, if you said that the male is normal, the male is affected and the female is normal, it will be a horrible mistake because now it won't affect the results. Later on, it will for sure. Later on, it will affect the results. Okay? So here,
أوكي
this is
thank you.
the phenotypic thing. Welcome. So this is the factorial analysis for the third part. You can, for example, take a screenshot for this if you wanna make sure that you solve it correctly during the homework. So this is the factorial analysis. Here, I'm talking about autosomal. Sometimes maybe it's a sex link. Let's see. Sex link. What is going to do? Let's see here. I'm going to remove this. Okay? Pay attention to me, please. Here I'm going to remove this. And I'm going to talk if it's, well, for example, it's sex linked. Okay? If it's sex linked, what do we have to do? If it's sex linked, for example, let's say it's located on X and Y, for example. Okay? If it's located on X and Y, what it will be? It will be what? For example, here, normal. So X and Y, let's say N small. And here abnormal will be X and small, X and small. Okay? What are the gametes? X and capital and Y and small. So here, this one will be what and this one will be what. So this one will be 1 over 2 and this one will be 1 over 2. Here I'm talking about if it's sex linked, okay? Here, this one, it's X and also will be 1 over 1. Okay? Here, if it's located, for example, on X and Y. In the factorial analysis, the same steps and the same concept it will be. How? It will going to work the same way and the same concept. Okay? If it's cycling, the same way and the same results it will be. Okay? For example, if it will be. So here, let's see here. For example, here, the male, it will give xn 1 over 2 and yn small 1 over 2, let's say. And here, xn 1 over 1. So here, xn, xn small, it will be 1 over 2. And xn small, yn small, it will be 1 over 2. So here, xn capital, xn small, it will be normal, 1 over 2. So 1 over 2, it will be normal. And xn small, yn small, it will be abnormal or affected. Here, wait a minute. If I ask you, what is the risk for having an affected female? Where is the affected? The affected is here. It's only a male. So there is no chance for having an affected female. So you have to pay attention to this. What is the chance of having an affected boy? It's 1 over 2, since it has x and y and. What is the chance of having affected children? It's half. What is the chance of having normal? It's also half. So here you have to pay attention. If it's sex-linked, you can work it like this, but instead you're going to put it on X or you're going to put it on the Y. Here is everything related to the gene localization, and you have to review all the notes related to this this chapter, related to the how to prove this. Review the question that we solved them together. Review the notes on your copybook, and be ready for your quiz.